shortest seek time first. Okay, SSTF means what? It is shortest seek time first. Okay, what do you mean by the shortest seek time first? Okay, let us take the same scenario. Here also we are having the head starts at what? 53. Initially, your read write head is on which track? 53rd track. And which all are the desired track you have to visit? It is 98, 183, 37, 122, 14, 124, 65, and 67. Okay, the same thing as we have seen it in the previous first come, first serve. Okay, and there the answer was how much? The access time, disk access time was 640 cylinders. But here, how we can reduce it? Let us see that. Okay, so what happens in this shortest seek time first scheduling algorithm is, as initially your read write head is on 53, we can see it here. Okay, let me just present it. Okay. Yes. So as you can see here, your read write head is initially at 53. Okay. So now, which is the next task on the queue? 98. In first come first serve, it was going as per the status of the queue. But here in shortest seek time first, that is not the case. Okay. It scans the entire queue. It scans the entire queue and finds which one is nearest to this 53. Okay. If you look at this queue, okay, in this queue, which one is the nearest? 65 is the nearest value to what? 53. Yes or no? Yes. Okay. So that is why in this shortest seek time first it will not go to 98, but it will first address, it will try to read the information which is there on 65. Now, where is the current status of read write head? It is on 65. Now, which is nearest to 65? Nearest to 65 is your 67. Okay. So now from 65, it moves to what? 67. Right? And when your read write head is on 67, which one is nearest now? 98, 183, 37, 20, 122, 14, or 124. Already these two are been done, right? So now currently your read write head is at 67. So out of these remaining tracks, which one is nearest for it? Of course, 67, 37 is nearest. So that is why your read write head moves from 67 to 37. Okay, so that is why you can see here it moves from 67 to 37. Now your current read write head is exactly at 37. So from 37 is 98 near, 183 is near, 122 or 14 or 124. Of course 14. So from 37 we will be moving to 14th track. Okay, so from 14th track, which one is near? 98th track. Okay, now from 98, which one is near? 122. And from 122, it moves to 124, and last it will be moving to 183. So if you see this here compared to your previous one, first come first serve, here there was lot many time your read write head was moving from left to right, right to left, left to right. There were more number of changes. Okay, that means your read write head was moving from left to right to left many times. But here if you see, it is only moving from, once it is moving to right, left, and then right. Okay, that means here the movement of your read write head is minimized. Okay, now if you remove the formula, what is the formula I have told? Initially, first you are moving from what? 53 to 65. So what is the displacement? 65 minus 53. Now when it is at 65, it is moving to 67. That means plus 67 minus 65. Okay, and after that, it is moving from 67 to 37. So plus 67 minus 37. And after that, plus 37 minus 14. After that, 98 minus 14. So when you add all this, what is the total answer you are getting? 236 cylinders. That means here the seek time is 236, which is very much less compared to your 640 cylinders. Okay, so that is what is the beauty of your shortest seek time first. Okay, when you are comparing it with your first come first serve, definitely this is the most efficient scheduling algorithm. But this efficiency, this advantage comes at the cost of some overburden. Okay, what is the overburden over here? The overburden here is that every time whenever you want to take the decision where you want to move, you should first check, or you should entirely scan this queue to check which one is nearest to the current read write head position. Okay, so this is one overburden. Okay, every time before moving you need to check which one is nearest, you have to calculate it and then take the decision. Okay, so this is just one overhead which is there on this scheduling algorithm, that is shortest seek time first algorithm. And also along with this overhead, there is one disadvantage, that is starvation. What is that? Starvation. If you see in this queue, 183 is the second request. 183 is what? The second request. But in this diagram, if you see, 183, 183rd track is the last track which is red. The last track which is red. That means 183 was already in the queue, but it was facing a longer starvation. Okay. The same thing if you compare it with your first come first serve, as and when 183 was at the second position, that was served at the second position itself. Here in first come first serve, starvation is not there, but in shortest seek time first, you are having much starvation on the higher side. Okay, so this is what is all about the algorithms, that is first come first serve and your shortest seek time first algorithm. Okay, so in the next video we will be seeing with the other two algorithms, and we will conclude with this scheduling algorithms. Okay.